All right, we'll do two quick examples here where we walk through how to graph from vertex form, and then we'll try and graph from zeros form. So the first thing we'll do is graph from vertex form. So that's where we have y equals a x minus h squared plus k. Okay, the vertical stretch is the a value. So here it's 2. Here it's -0.5. The horizontal shift is the h value. Now remember, this is the opposite of what it says in the equation. So if it says +1, it's actually -1. It's -1. So we write down left 1. Here we have a -3, so that means it's +3, which means it's right 3. The vertical shift is this number at the end, the k value. Sorry, this was the h value for the horizontal shift. The vertical shift is the k value. And so the k value here is -2, and we get to just copy that straight up. And that means right here we have a shift of 2 down. So we'll write down 2. Here we have a +4 value. So we'll write that down, and that means up 4. The axis of symmetry is always the h value. So notice here the h value was -1. Okay, again, it's the opposite of this, but it's the same as this, the h value that we stated there before. Here it's x equals 3, the opposite of this, but the same as the h value we just stated earlier. The maximum or the minimum value. So the max or the min is the k value. Okay, so the k value is 2 on this one. Because this parabola right here is positive, it means that it opens up, which means it has a minimum value. So we'll write a min of 2. Because this graph has a negative value, we know it opens down, which means it has a max. So we'll write max, and the k value is 4. The vertex is just h and k. So here we have h as -1 and k as -2. The other one here we have h as 3, k as 4. The y-intercept is always x equals 0, and then we can plug that into the equation to get the value. So here at the bottom we'll do for a, the y-intercept, we do y equals 2, 0 plus 1 squared minus 2. So y equals 2, 0 plus 1 is 1 squared minus 2. And 1 squared is just 1, so we have 2 times 1 minus 2, or y equals 2 minus 2, or y equals 0. So the y-intercept is 0. For the second equation here, we can do y equals -0.5, and we do 0 minus 3 squared plus 4. And we get y equals a -0.5. 0 minus 3 is -3 squared plus 4. So that's -0.5 times -3 squared. So -3 squared is -3 times -3, which is +9 plus 4. I'll work in decimals. You could type this into your calculator. -0.5 times 9 is -4.5 plus 4. So that means y equals -0.5. Okay, now we get to graph all the parts here. So for A, we have a vertex at -1, -2. We have a axis of symmetry at x equals -1. We have a y-intercept at 0. And because the stretch value is 2, we know that from the vertex it goes up 2 to the right and up 2 to the left. Okay? So that means we have this as our parabola. Okay, that's a good drawing for this class. We're happy with that kind of drawing. The other one has a vertex at 3, 4, so 1, 2, 3, 1, 2, 3. Right there, we have an axis of symmetry, okay, at x equals 3. We have a y-intercept at negative 0.5 right there. So if it's at negative 0.5, make that a little bit cleaner, and that's 3 away from the axis of symmetry, that means another 3 away, and we'll have the other side of the parabola, okay, the symmetric part. The other thing you might notice is, again, here we have a stretch value of a negative half. So that means from the vertex, it's going to go down. It's going to go down 1/2 on either side, from the right and to the left. Okay? So I'll label my vertex. I'll draw a line going through like that. So notice that we got our first step graphed and the y-intercept graphed. We've got 5 nice points on this graph. All right, so that's how to graph from vertex form and to label all these parts in the chart. So now we're going to try zeros form. So vertical stretch, as before, it's the a value. So here it's 2. Oh, I should write this. Y equals a, x minus r, x minus s. So a value here is 2. And the second one, we got a negative symbol, so that implies that we have a negative 1 as our stretch value. The zeros, again, because it's in the brackets there, it works the opposite. So it's not positive 1 and positive 3. It's negative 1 and negative 3. For this one, it's negative 1, opposite of positive 1. Because this says negative 2, it's actually positive 2. So it's negative 1 and 2. So this is your R and your S value in the formula. Axis of symmetry occurs at R plus S divided by 2. So let's do this right here. So for A, we get the 2 values of the x-intercepts are negative 1 and negative 3. We're going to add them up, divide by 2. So negative 1 plus negative 3 is negative 4 over 2. And negative 4 divided by 2 is negative 2. So the axis of symmetry is x equals negative 2. For the B here, we have the second one there. We have x-intercepts at negative 1 and positive 2. We add them up, we divide by 2. So negative 1 plus 2 is 1. Again, copying that, divide by 2. And 1 divided by 2, we could say that's 0.5. Or we could say it's 1/2. All right. Max, min, value. So for the first one up there, what we're going to do always is we're going to plug in the axis of symmetry. Okay, so if we plug in the axis of symmetry, we're going to plug in x equals negative 2 for the first one. So that gives us y equals 2. And negative 2 in for the x value here, plus 1 times negative 2 plus 3. So that gives us y equals 2. Negative 2 plus 1 is negative 1, and negative 2 plus 3 is 1, which means that y equals negative 2. Okay, so it hits some kind of value, a max or a min, at negative 2, which means the vertex is at negative 2, by the way. But let's go back. Is this a maximum or a minimum? Well, same thing as last time. Here we have an a value of positive 2. That means that it opens up, which means it has a minimum. Okay, I'll write down the second one up below there. So we'll continue down here, B. So we're going to solve for this spot here. So how do we find that max or min value? Again, we plug in the axis of symmetry. So axis of symmetry is x equals 0.5. So that gives us y equals negative 0.5 plus 1, 0.5 minus 2. So y equals negative, and 0.5 plus 1 is 1.5. And 0.5 minus 2 is negative 1.5. And if you multiply those out, you get positive 2.25. So we hit some kind of maximum or minimum of 2.25. As we said before, it's negative, so therefore it opens down, which means it has a maximum. The vertex, again, is just our h and our k value. So our h value is right here. It's the axis of symmetry. It's 0.5. And the k value is what happens right here in the maximum value, just like before. So it's 2.25. All right, we're almost done here with this chart. Last thing here is the y-intercept. Well, y-intercepts always happen when x equals 0. So we're going to go into A here, and we're going to take care of this y-intercept. So x equals 0. So we got y equals 2, 0 plus 1, 0 plus 3. Just copying out the equation. So that's 2 times 0 plus 1 is 1, and 0 plus 3 is 3. So y equals 2 times 1 times 3, which is 6. And for B, we have the y-intercept of, again, x equals 0. We plug it into the equation, so we get y equals negative 0 plus 1, 0 minus 2, which gives us y equals negative. And 0 plus 1 is 1, and 0 minus 2 is negative 2. So y equals 2. All right, let's make our graphs. So let's kind of talk about the logic days while we're doing it. So -1 and -3 are your zeros. The axis of symmetry, it makes sense, is halfway between those two. Sorry, I wrote the wrong number there. That's -2. The vertex was -2, -2, so it's down here. The y-intercept was 6, 1, 2, 6. And if there's a point 2 over here, then there's a point 2 over here. So here's your other side of that parabola. And now we can draw it through. All right, for the other side here, we have x-intercepts of -1 and +2. We have an axis of symmetry at 0.5. Notice that that's exactly halfway between those two x-intercepts. And the vertex is at 0.5 and 2.25. So it's just right here. Just a little bit above this 2 line. You'll also notice that the y-intercept was 2. So here's our y-intercept, which would mean there's another point over there. So it just goes like this and like that. And that is how you graph from zeros form.